The formula for the area of a parallelogram is area is equal to b times h, where b is the length of the base and h is the length of the height. The formula for the area of a rectangle is area is equal to L times W, where L is the length of the length and W is the length of the width of the rectangle. And the formula for the area of a square is the area is equal to S squared, where S is the length of a side of the square. Since squares and rectangles are also parallelograms, the formula for the area of a parallelogram also works for squares and rectangles. For a square, one of the sides can be thought of as the base and another side can be thought of as the height. For a rectangle, the length can be thought of as the base and the width can be thought of as the height, or vice versa. Well, here's three examples: a square, a rectangle, and a parallelogram that is neither a square or a rectangle. Well, we make the bottom sides from each one of these the base, B, and then we find the heights of each one, and you can see for the square it's an adjacent side to the base, and for the rectangle it's the width, and for the parallelogram at the bottom we need to find a new length. It's not the same as one of the four sides, it's the distance from the base to the opposite side marked by the dotted line in green. Now we draw some red segments where we connect opposite corner points, also known as vertices, and these red segments are called diagonals. And I think you can see that each one of these diagonals divides each shape in half. And you can also see that half of one of these parallelograms is a triangle. So that gives us the formula for the area of a triangle. It's 1/2 times the length of the base times the length of the height, or saying it quickly, 1/2 the base times the height. Well, here's four triangles, and instead of starting with parallelograms and cutting them in half, we'll start with the triangles and try to figure out what were the parallelograms that they came from. There's the first one. Now you can see the black triangle is half of a larger parallelogram. There's the second one. Now it looks like the black right triangle is half of a square, perhaps. And this black triangle perhaps is half of a rhombus. We're not sure, but it looks like all four sides might be the same. And at the bottom we have a right triangle, which is half of a rectangle. So for each one, we have the bottom side we're going to mark as the base, and then we're going to find the height of each one of these black triangles, which also matches the height of each one of the four parallelograms that have now been marked out. Well, there's the height of the first one. And notice the height of the square is identical to one of the sides of the square, and it's also the height of half of the square, which is, of course, the original black triangle. And here we have a height of a triangle, which is the same as the height of the parallelogram, which we noticed might also be a rhombus. And then for our final shape, which the whole thing is a rectangle, and half of it is a right triangle, and the height is the same as the width of the rectangle. Once again, we've shown that the formula for the area of a triangle is that the area equals 1/2 times the base times the height. Any of the three sides of a triangle may be used as the base. So here's a right triangle, and we put that little symbol in the bottom corner to show that it's a right angle. The little symbol is not part of the triangle. It's just a symbol to indicate that that angle is a right angle. So on this one, the base is the bottom side and the height is the side on the left. And in a right triangle, the base and the height are also known as the legs of the right triangle. The third side, the one that's unmarked, is called the hypotenuse. Here's that same right triangle put up so that the shorter of the two legs is on the bottom. So that now becomes the base, and the longer of the two legs becomes the height. So now we take the same triangle one more time, put it down so the hypotenuse is on the bottom. It becomes the base, and we have to find a new length. The height relative to the hypotenuse is not one of the other two sides. So there's really four parts to this triangle that we need: the length of each of the three sides and the height relative to the hypotenuse. To get the area, you only need 2 out of those 4 lengths. Any of the 3 sides of a triangle may be used as the base, and there is a different height for each base. And so in this triangle, we've colored each side a different color, and we've drawn the height from the opposite vertex down to the green side, which we're now calling the base. So the solid green segment is the base, and the dotted line in green is the height relative to that base. Now let's take a look at the red side. We kind of have to stand sideways to look at this, but the red dotted line is the height from the red side up to the opposite vertex. And there's one more relative to the blue side. And you might notice that all three heights coincide in one point, and that's true. That always works that way. If you find all three heights of a triangle, they will always intersect in the same point. So now let's get out a ruler and see how we do. We measure the red side of the triangle and the red height. And then we measure the green side and the green height. And then the blue side and the blue height. And now we apply our formula. 1/2 times the base times the height. We've used a calculator, and for the red, our answer is 27.9 square centimeters. For the green, it's 27.14 square centimeters. Not quite the same, but between 27 and 28 both times. And with the blue, we get 27.5, kind of in the middle of the other two. So it turns out this triangle only has one area, but to get it exact is difficult because it all depends on the accuracy of our measurements with our trusty ruler. So we've tried one more method. We've got a piece of software called the Geometry Sketchpad, and we've copied a very similar triangle into Geometry Sketchpad and asked Sketchpad to measure it to the nearest hundredth. And using the red side and the red height, you can see it gets 30.77 square centimeters for this triangle. And then we ask it to measure the green side and the green height, and it got different numbers for the two greens, but when it took 1/2 the base times the height, it still got 30.77 square centimeters. And then finally, we asked the software to measure using the blue side and the blue height, and it also got 30.77 square centimeters. And the little M's before those symbols, if we go to the very top of this frame, where it says M and then it says AB, that means the measure of segment AB. Or because the segment is part of a triangle, we could say the measure of side AB. Here's an obtuse triangle, and when you have an obtuse triangle, the first height over to the longest side goes right down the middle of the triangle like we're used to. But to get the height relative to the blue side, we have to extend the blue side and then find our height, and it goes outside of the triangle, and the same with the green side. But if we extend all those heights, they still come together in the same place, only this, the place where they come together, is outside the interior of the triangle. And now let's try 3 problems. While we can find a height relative to each base, we use what we're given. And in this one, we're given the 3 sides and a height relative to the side that's 8 centimeters long. So we start with the perimeter. We don't use the height. We use the 3 sides, 11 plus 11 plus 8, and the perimeter is 30 centimeters. To get the height, we use the 10 and the 8. 1/2 times the 8 times the 10 is 1/2 of 80, which is 40 square centimeters, and that's the area of this triangle. Here's an obtuse triangle. We have the length of each side and the height relative to the side that's 10 centimeters long. So the perimeter, of course, is 10 plus 14.8 plus 7, or 31.8 centimeters. In the area, we need the 6 and the 10. 1/2 times 6 times 10 is, of course, 30 square centimeters, the area of this triangle. And in our final example, we have a right triangle. So we only need 3 numbers here, because the 5 centimeters is also the height of this triangle. But first, let's do the perimeter. 5 plus 12 plus 13 is 30 centimeters, and the area, of course, is 1/2 times the 5 times the 12, or 1/2 of 60, which is 30 square centimeters. The formula for the area of a triangle is that the area is equal to 1/2 the base times the height. Any of the 3 sides of a triangle may be used as the base. There is a different height for each base. Another word sometimes used for height is altitude.